This is question 10 on chemistry from the 2018 BMAT. So we're told that iron ore contains this Fe2O3 compound and that iron is extracted from it using carbon monoxide in this reaction. Iron oxide plus carbon monoxide forms iron and carbon dioxide. This reaction has a delta H of minus 30 kilojoules per mole, and the reaction is slow and it must be heated. And so we're given some statements and asked which is correct. That's the iron in Fe2O3 loses electrons to form Fe. The oxide ions in Fe2O3 each have a minus 6 charge. The Fe2O3 acts as an oxidizing agent. The reaction is endothermic, and the reaction is an example of electrolysis. So let's look at statement 1, which says the iron in Fe2O3 loses electrons to become iron. Is this true? Well, why don't we look at a simplified half equation for Fe2O3 forming elemental Fe. Is this a gain or a loss of electrons? Well, why don't we look at oxidation states? So, how do we find out the oxidation state of the iron in this? Well, we need the rule that oxygen is always minus 2, and we've got 3 of them, which makes minus 6. So, each ion has to be what? Plus 3 to make it up to 0. And what's the oxidation state in elemental iron? Well, we know elements are always 0. So the ion's going from plus 3 to 0, so has it gained or lost electrons? It has gained electrons because the oxidation state has become more negative. So seeing as we've gained rather than lost electrons, we can say A is wrong. Now B tells us that the oxide ions in Fe2O3 each have a minus 6 charge. Well, we know that the total charge of all the oxygen is minus 6, but is this correct? Well, the oxide is actually the minus 2 bit, or each individual oxygen, O2 minus. That's the definition of oxide. So we can say this is wrong. So in part C, we're told that the Fe2O3 acts as an oxidizing agent. Is this correct? Well, what does an oxidizing agent do? It causes the other species to be oxidized while itself being reduced. Now we know that it's reduced because we saw that electrons are gained in this process, but let's check that the carbon monoxide is oxidized. So if we do another simplified half equation, we've got CO forming CO2. What are the oxidation states in this process? Well, we know oxygen is always minus 2. So what's carbon? In this case, it has to be plus 2 to make 0, and in this case, it has to be plus 4. So is this an oxidation? Well, you can see that because carbon's gone from plus 2 to plus 4, we need to have lost 2 electrons. So this is indeed an oxidation. So it's been oxidized by the Fe2O3, so it must be an oxidizing agent. What about part D? So we're told the reaction's endothermic. Is this correct? Well, we can just quickly look at the enthalpy change that we're told. It's negative, so you've just got to remember which way around is endo or exothermic. Is it endo? It's in fact exothermic, because heat's given out, so it's a negative enthalpy change. And finally, we're told this reaction is an example of electrolysis. Is this correct? Well, we know electrolysis always involves oxidation and reduction, and we're forming an element, which is common for electrolysis. But the clues in the name electro means we actually have to use a current, an electrode, to do this, so this actually isn't electrolysis. In fact, we're just using heat to drive the reaction rather than a current. So this is wrong, and our final answer is C.